to everyone. Today we are from Group 3, IED Principle. We want to present our project title, which is Tapai Maker. This is the problem statement. First, all tapai will be weighted about 50 grams, and if done manually, will take a long time to complete. Second, workers need to put tapai on the scales before packing. And the third problem is tapai volume is not uniform, which is it has a different weight. Next.
Suara kena kuat lah.
Okay, there are three objectives that we get from this project. Number one, to build a mechanism to reduce the time taken. Second, to ensure the process become more efficient. And the last one is to fix the packaging measurement. So next, this is our project problem, cause of the problem. Okay, as you can see, this is our fishbone. The cause of the problem. The main problem of our project is tapai not 50 gram weight. Okay, there are 6 factors. First, material, which is wrong specification of material. Second, measurement, which is wrong size of the mold. Third, machine malfunction. Fourth, method, which is wrong production procedure. Fifth, environment, which is too hot, too cold, too humid. And the last one, the factor that we get is people, which is employer mistake. That's all for fishbone.
Senyum sikit. Okay, cuba.
Okay, next is requirement of the machine. So there are 4. So it involve multidisciplinary field of study, which is electrical, mechanical, and also electronic. So it is able to produce data that displays and improve progress. It is a closed loop system and uses sensor to measure weight of the packaging. Okay, next. Okay, this is what we drew for our brainstorming to design our machine. As you can see, we have 4, which is 1, 2, 3, and 4. So we chose number 2 because it is more suitable for our problem. So this is our decision matrix table. As you can see, solution 2 obtain more points, so it is the best for us lah. Okay, next. So 3D sketching, we use SketchUp to draw our 3D sketching. So this is the top view, right view, full view, and also the front view of our machine. So this is our mechanical drawing, which we use AUTOCAD. So this is our front view, this is our back view, and this is our side view. Okay, that's all.
Bismillahirrahmanirrahim. So this is our exploded view of our project. So this part here, explain to you, this is the solenoid valve sensor. So what it does is, this is a coil, and this is bronze thin bearing, stainless shaft, and there's a spring inside here. So our programmer will do coding circuit, and then when the current flow, it will cause magnetic flux. So the spring does control the direction of the push of the spring, so that the tapai filling will be open and closed. Okay, next.
Okay, this is the flow chart of the system. So mainly, this is how the machine is working. So when the machine is on, and the push button is pressed, conveyor will moving toward the machine. So when the sensor detect block, the valve will open and to the load on top the load cell. So load cell will measure until 50 grams. So when the tapai filling is same with 50 gram, the valve will close. So the solenoid from the machine will push the tapai filling into the mold on top of the conveyor. So the conveyor will start moving to the packaging machine, and the machine will not stop until the push button is pressed. When the push button is pressed, when the stop button is pressed, so the conveyor will stop moving, and the machine will stop. So next. And this is the electrical circuit of the prototype that we have to create. So this is mainly how we do using the Arduino. So in here is the controller. We use L239D, which is the controller for the motor. We use the motor DC, which is 12 volt, and this is the solenoid controller. So by the direct input from the Arduino, it will control when the solenoid will push, will retract or push. So it will function when the sensor is detect something. And this is the sensor. We use the two sensor, and at here we use we do the solid PCB for the solenoid controller. So this is the schematic, electrical schematic, and this is how the PCB at the board.
Okay, for the parts and component, this is load cell, which is detect the load of the tapai filling to 50 gram, and this is IR sensor. IR sensor detects the object, and this is push button. You know, push button, start off. You press it start, and then you press it again off. This is, what is this, man? Conveyor. This is conveyor. Conveyor. This is solenoid valve. This is the one that I tell you, if the magnetic flux, it will push the spring, so the valve is open and close. This one the control, and this is the solenoid. On top of this thing, inside is solenoid, and this thing is solenoid valve. So next. Okay, for our cost of materials of our project, I tell you the crazy number first. So the total is 16,000. So even my PTPTN didn't have that much. So what our method is, we do it ourselves. So instead of buying the actual machine on the market price right now, 1400, so we do it ourselves by using DC motor 12 volt, 5 ringgit. Solenoid valve is 32 ringgit. Solenoid motor is 30 ringgit. Load cell 50 kg is 10 ringgit. And belt, our DIY belt is 10 ringgit. And our control, L293D IC is 5 ringgit, very cheap. IR sensor, do you know? 5 ringgit. We use 2 IR sensor, which cost 10 ringgit. And from 16,000 ringgit, we cut down until total of 100 ringgit. Crazy number. Okay, so I hope you like our project. So that's all from us, and I see you in the next 2 semesters. Thank you.